This is Katie with TutorPug, and I wanted to do a quick introduction to hypothesis testing for statistics. There are many different ways that you can do hypothesis tests, or there's many different tests that you can do. I want to give you an introduction on just the basic structure of it, what you're doing, and some decisions that you have to make every time. Okay. This statement says that the National Center for Health Statistics, NCHS, reports the mean systolic blood pressure for males aged 35 to 44 years is 128, and the standard deviation in this population is 15. The medical director of a large company looks at the records of 72 male executives and finds the mean systolic blood pressure is 126.07. Is this evidence that the company's blood pressure is different from the population? And you are to test this at 5%. So I'm going to be running through this fairly quickly. The first thing you have to do is state your hypotheses. Well, and you have to determine based on the language and the problem, is your alternative hypothesis one-tailed or two-tailed? And that is determined by one keyword or a couple of keywords. This particular medical director wants to know if the executives in the company are different from the population. This medical director isn't stating they believe the executive's blood pressure is higher than the population or lower than the population, greater than or less than, just different. So this magic word, different, tells us how to structure our hypotheses, and it tells us that we have a two-tailed test. If it had said greater than or less than, then we would do a one-tailed. The alternative hypothesis, which some instructors call HA and some instructors call H1, is going to be that the mean, and we always use population symbology in hypothesis statements, the mean is different from the value given in the problem of 128. So if the general population, if the National Center for Health Statistics, which has done research for generations, has determined that 128 is kind of where the population shakes out, this particular medical director wants to see if his sample of these executives is different from what the population standard is. So that means the null would be equal to 128. Notice there's a few things here. First of all, the null always gets the statement of equality. Equality. The null is going to have either the solid equal sign, or if we're doing a one-tailed test and we have a greater than or less than symbol in the alternative, the null will have the opposite greater or less than symbol with the equal bar on the bottom. Also, all hypotheses always use population symbols. They never, ever use a symbol that's associated with a sample. So if you see an X bar in a hypothesis statement, that's wrong. So first of all, you state your hypotheses. Now you have to determine which test to run. A z-test, a t-test, an f-test, a chi-square test. All of that depends on what you're testing and what you have available. So in this example, we are comparing means. We're comparing a sample mean of male executives to a population mean. So we're testing means, which means for the purposes of very intro statistics, we're either going to do a z-test or a t-test. Okay, well, how do we decide? The problem tells us that we have the standard deviation of the population. The problem is giving us sigma. When you're doing a test of means and you know sigma, or you're given sigma, or you're told sigma, that is a z-test. So you will be calculating for your test statistic a z-test statistic. And the z-test statistic formula is your sample mean minus the population mean over sigma divided by the square root of the sample size. Sample mean, population standard deviation, sample size. That's what those symbols mean. So once you determine your hypotheses and the test that you're going to run, now before we even calculate that, let's come over here and draw. This is very critical because this tells us at the end of the day, are we going to reject the null or not reject the null? And that's the whole goal, is to make that decision, reject or not reject. So we need to have an idea of what value for this guy will let us make that decision. And it's a comparison. So since we're two-tailed, we're going to have two rejection regions. We're going to put a rejection region in each end of the normal curve. We're doing a normal curve because we have a z-score. Z-scores follow this distribution. Two-tailed, two rejection regions. And the rejection regions are always out in the tails. Okay, this is a number line. This is a number line with 0 in the middle as the mean because we're using the standard normal distribution. There are positive values up here. There are negative values down there. It's a number line. So in hypothesis testing, one of the ways we make the decision to reject the null or not reject the null is by comparing a calculated value from our data to a critical value or values that come from the z-table. Now, there are many different ways to find these. You can either memorize a few standards, or you can use a z-table, or you can actually use your calculator. But I'm going to tell you, for the sake of ease, that at 5% significance, which impacts these guys, and two-tailed, which impacts these guys, the critical values that come from the z-table are 1.96 and his negative counterpart. So what this means is, if my calculated value is more extreme than either one of these, meaning if my calculated value is bigger than positive 1.96 or smaller than negative 1.96, that lands my data in the rejection region and I reject the null. So if we do our test statistic, we calculate the value of our test statistic, that's where we're going to plug in the values from our study into our equation. Okay, well, our sample mean was 126.07. The population mean is 128. We are told that the population standard deviation is 15. And our sample size, we took a sample of 72 executives. So that's what my equation, that's what I'm calculating from my data. That's what I'm calculating from my data. So I crunch those numbers really quick and very carefully. And I get a z value of negative 1.09. This is my calculated value. These are the critical values that I'm comparing it to decide, do I reject or do I fail to reject? So if I plotted this value on my number line, that would fall approximately there. It would not fall in the rejection region. Negative 1.09 is not farther to the left on the number line than negative 1.96. It doesn't make the cut. Therefore, I fail to reject the null, which means I'm kind of stuck with it. If I fail to reject it, some classes say retain. I was trained, you reject or you fail to reject. But if you want to think, okay, fail to reject means keep or retain. So I would retain the null. That's my decision. The conclusion is, if I retain the null, I conclude that the company's blood pressure is not significantly different from the population. It's, yes, 126.07 is less than 128 mathematically, but statistically speaking, it's not a significant difference. It's not different enough to make broad, sweeping generalizations or decisions about healthcare programs or insurance. So you state your hypotheses. Step 1. You figure out what test you're going to run. Step 2. You draw your curve and determine your critical value or values. That's your third step. Then calculate the value of your test statistic by hand, on a calculator, maybe it's given to you, and then you compare the test statistic calculated to the critical value or values and make your decision to reject or not reject. Then you state your conclusion, take a bow, walk away. Practice hypothesis testing. It's not that difficult, but it does take some getting used to. Have a great day. Thanks.